Hello everybody, so this is your third and final algebra review note video. When you're done with this video, you can start and complete the final algebra review, the day 3 homework, and after you finish that, you should have all 3 homeworks submitted. If you have any questions, please contact your teacher about those specific problems so they could help you out possibly in a Zoom or via email, however works best. So let's start this review by go ahead and start with the opener. You can go ahead and pause the video and try that opener on your own. So if you haven't opened a copy of this in Notability yet, please do so. Okay, so if you just need the first step, maybe you're like, oh, I was going to do it on my own, first step. I need to solve this equation. Okay, it's higher than a quadratic. It's actually, it goes linear, quadratic, cubic, quartic, quintic. You don't need to know that, but this is a quintic. So it's higher than a quadratic. And in order to solve this, the first thing you always look for is a GCF. Okay, so if it's higher than a quadratic, still always look for a GCF. Is there something that these two have in common? Yes, x. So now I'm going to factor out the x. Now I have x to the 4th minus 81 is equal to 0. Okay. All right, so now remember, I want to see if this is still factorable, and it is. Okay. Now I could say I can set each factor equal to 0 and solve, but I'll be missing out on solutions if I try to solve that quartic equation right now. So I'm going to keep factoring. Okay. Now remember, this is a perfect square, this is a perfect square, it's a difference. So this is a difference of squares. What do I multiply? That's the same exact thing to get x to the 4th. It'd be x squared and x squared. One's positive and one's negative because there is no middle term, they cancel out. And then the number that you multiply by itself to get 81 is 9, equals 0. Okay. I could still keep asking myself if this is still factorable. Like, is this factorable? The answer is no. Is this factorable? The answer is yes, and keep factoring. But I already know how to solve this, right? If I set it equal to 0 and solve, I know how to solve by square rooting. So I'm going to stop here. So solving by square rooting is what I'm going to do with these actual 2 factors right here. But in the meantime, I'm going to set each factor equal to 0. There's 3 factors. 1, 2, 3. X equals 0. X squared plus 9 equals 0. X squared minus 9 equals 0. And now I'm going to solve each one. Okay, so first equation I have to solve for x. It's already done. There's one of my solutions. Second equation I have to solve for x. So I'm going to subtract 9 from both sides. X squared equals negative 9. And then remember, I'm going to square root to solve. And whenever you square it to solve, you have to account for the positive and negative answer. So x equals positive or negative. It's a negative number, so I know there's going to be I in my answer. And now the square root of 9 is 3. So plus or minus 3i. So there's 2 more solutions. All right, last equation that I have to solve here, add 9 to both sides. Square root plus or minus, square root plus or minus. X equals plus or minus, and then the square root of 9 is 3. So 2 more solutions. So if you look, you have 5 solutions total. If you look at the degree here, it was 5. That's no coincidence. Okay. Next one right here. I'm going to go ahead and tell you the answer in case you just want to fast forward quickly through because you just want to know if you got it right. The answer is x equals 1 plus or minus root 7. So if you got that, you could fast forward to the next one and check that. If you didn't, here's where you possibly made a mistake. So this has 3 terms. There is no GCF. So I look to see if it's factorable. 2 numbers that multiply to give you negative 6 and add to give you negative 2. There aren't any of those 2 numbers, so I'm going to use Pythagorean Theorem. X equals the opposite of b, which is 2, plus or minus the square root of b, which is negative 2 squared. Make sure that negative 2 is in parentheses and the square is not. Minus 4 times a, which is 1, times c, which is negative 6, all over 2 times a, which is 1. All right, we're ready to simplify. So I have x equals 2 plus or minus the square root of negative 2 quantity squared is 4. Now I need to multiply these three numbers. That's positive 24, so plus 24 all over 2. X equals 2 plus or minus the square root of 28 all over 4. Now remember, the next step is to see if the square root of 28 is simplifiable. The square root of 28 is simplifiable because the perfect square of 4 goes in there 7 times. Square root of 4 is 2, so this is 2 root 7. So x equals 2 plus or minus 2 root 7 all over, I don't know where this 4 came from. Hopefully you caught my mistake there. I was supposed to copy this number 2. And then last but not least, I have to divide. So divide by 2, x equals 1 plus or minus, divide by 2, root 7. And there's your 2 answers. Okay. Go ahead and pause the video if you didn't move on to this one yet and try this one on your own. And then come back and see how you did. Okay, so vertex. First thing I'm going to do is find the vertex. This is in standard form, where it's y equals ax squared plus bx plus c. So I'm going to find the x value of the vertex by using x equals opposite of b, negative 8, over 2 times a, which is negative 2. So that is positive 2. That value is 2. Now to find the b value, I'm going to plug in 2. So I'm going to find f of 2. Negative 2 times 2 squared plus 8 times 2. All right, make sure you're doing order of operations. I'm doing 2 squared first. That's 4. Then multiplication left to right. So now I can do negative 2 times 4, which is negative 8, plus 8 times 2, which is 16, and that's 8. So my vertex is 2, 8. My y-intercept, remember, I plug in 0 for x to see what I get for y. If I plug in 0 here and here, I get 0. So 0, 0. Remember, these graphs are symmetric. So you have a axis of symmetry right here. And that means that there's a point reflected over that line right there. So there's another point right there. X-intercepts, set your function equal to 0 and solve, right? So set y equal to 0 to solve. So you're looking for something comma 0 here, right? And there's possibly 2. There's possibly just 1. Or there's possibly none, right? So let's check. If you look here, you can already see what they are, but let's make sure we know how to do this algebraically. So 0 equals negative 2x squared plus 8x. All right, so I need to factor this so I can solve it. I'm looking for a GCF. The GCF is 2x, but I want to get rid of this negative also right here. So I'm going to factor out a negative 2x out of each. Now I can set each factor equal to 0 and solve. So I have negative 2x equals 0, x minus 4 equals 0. Divide by negative 2, I get x equals 0. So 0, 0 is one of my x-intercepts. Add 4, x equals 4. So 4, 0 is the other one. If you look, they're already graphed. So I knew that those, they were that already. Okay, but what happens if it isn't already on your graph, right? So you have to make sure you know how to do it algebraically. Okay, so if you look, we only have 2 topics really to cover on this day, so it's nice that you only have 2 more topics that you have to brush up on here. Okay, so first one is exponent properties. Okay, so let's get started on this one. Okay, actually before we get started, I'm going to remind you of your exponent properties. So if you have a to the x times a to the y, right? So if you have 2 terms with the same base and you have exponents here, what you're going to do to simplify it, and it's being multiplied, okay? You're going to keep the base of a and you add your exponents. Now, if you have a to the n, let's use to the nth power, right? So if you have a power raised to a power, what you're going to do is you're going to keep the base and you multiply your exponents. If you had two bases that are the same divided by each other, you're going to keep the base and subtract your exponents. And what am I forgetting? Which one? I think, and then a or x to any power. So if you have a base to any power, or sorry, not to any power, to the 0 power, it is equivalent to 1. Okay. So let's go ahead and see this first one here. So this one, I have 3x to the 4th, y to the 5th, z to the 0, all to the 2nd power. So first thing that I'm going to notice is the z to the 0 power. Anything to the 0 power is the same thing as 1. So what I'm going to do is I'm going to cross it off because it's the same thing as 1. You don't have to write 1 there, but that's what it's equivalent to. Okay? All right, so now I'm going to go ahead and square everything. I have 3 squared, which is obviously 9, but I want to make sure you're seeing what we're doing here. Then I have x to the 4th squared. So it's like this, x to the 4th squared, right? Power to a power, that's x to the 8th. You multiply your exponents. Same idea, y to the 10th. And then now I have times 2xy cubed. Okay. Now I'm going to change this to a 9 just because I could have done it in the first place. All right, so now I'm going to multiply these two. So I have my coefficients, 9 times 2, so that's 18. Now I have x to the 8th times x to the 1st. Realize this is x to the 8th times x to the 1st. Keep your base, add your exponents. That's x to the 9th. Same idea for the y's, y to the 10th. And there's your answer. All right, this one's division. Okay, first thing I'm going to do is I'm going to look at just 10 divided by 2. So like realize if you just saw that, like look at this right here I'm looking at. 10 divided by 2, that's 5. All right, and that's going to simplify to 5. So I'm going to change it to 5. Let me get rid of all that highlight there. This becomes 5. This becomes 1, but once again, you don't have to put that 1 there. Okay, now you can subtract your exponents since it's division. You can do x to the, and then 3 minus 8, and get x to the negative 5th, and then we can talk about negative exponents and how you can't have them. So you take your negative exponent and you bring it to the denominator, so that's 1 over x to the 5th. Notice that's 1, 2, 3 steps here. Or another way of doing it is you can look at it and you can say, okay, I have x's both in the numerator and the denominator. Where are there more of them? There's more in the numerator, so they're going to stay. I'm going to get rid of all 3 in my numerator, but that means I have to take away 3 from my denominator. So now instead of x to the 8th there, I have x to the 5th. So notice that gives you x to the 5th in your denominator that way. All right. Now on to our y's here. You can't have negative exponents, right? So the first thing I'm going to do is I'm going to say, all right, this y to the negative 6 can't be here. So I'm going to bring it down to the denominator. And now I have y to the positive 6th down there. This y to the negative 2nd can't be in the numerator, so I'm going to bring y squared up here. This is not the only way of doing it. It's just the first way that I think of. All right, now you can do this the exact same way you did the last ones. Is this exact same way that you did the x's. So there's 2 y's up top, 6 on the bottom. There's more on the bottom, so they're staying. I'm getting rid of all of them on top, getting rid of the 2 from here, so now there's 4 on the bottom. Now I'm ready to write my final answer. It's a fraction. All that I have left in the numerator is a 5, and in my denominator I have x to the 5th, y to the 4th. If you did it a completely different way and still got the same answer, your way works. Okay, last but not least, we have to talk about rational expressions. Rational is just a fancy word for fraction. And then we have this right here is a rational expression because it's not an equation, right? So fraction, that's not an equation. So we are going to talk about simplifying, okay? So in order to simplify a fraction, so if I had 50 over 100, okay? Everyone looks at that and says, that's half, okay? I agree with you. That's 1 over 2, okay? But the reason that it is 1 over 2 is because 50 is 2 times 5 times 5, right? 100 is 2 times, I'm doing it in my head here, 2 times 5 times 5. Now that the numerator, I just factored it. I broke it up into factors, all right? Now that the numerator's factored and the denominator's factored, I can cancel out common factors from the numerator to the denominator. So there's a common factor of 5 right here. There's a common factor of 5 right here. And there's a common factor of 2 right here. So if you look to see what's left over, 1, because there's not 0 up there, 1 in the numerator, 2 in the denominator, 1/2. Now you might be saying to yourself, that's the stupidest way I've ever seen. That's the way you were taught when you were in grade school. You broke it up into prime factorization, okay? But then you got really good at it because you started saying, I can do this faster without doing this. When you see this, you have to keep in mind you're doing the same thing. In order to simplify a fraction, you must factor it, okay? So, factor the numerator. 2 numbers that multiply to give you -2 and add to give you -1. That is -2 times +1. Don't forget to divide by your lead coefficient of 1, and those are your x's. So x minus 2, x plus 1. Once again, if you factor by guess and check, you factor a different way, you do you. All right, bottom, there's no GCF. It's 2 terms, so is it a difference of squares? Yes, that factors to x plus 2, x minus 2. Now I can cancel out any common factors, x minus 2 and x minus 2, and I'm left with x plus 1 over x plus 2. Now people go crazy and they're like, can the x's cancel? Do you get 1/2? Absolutely not. This is your factor. An x plus 1 can only cancel out with an x plus 1. So if the addition sign wasn't there and if it was an x and a 1, then you have 2 different factors. I know it's a lot of explaining, but this is what I would do in class as more information. Okay, next one here. This is multiplying 2 rational expressions and simplifying. So what you're going to do is you're going to do it the exact same way as if it was just the 2x right here. You're going to simplify it by factoring it. You're going to factor everything in the second gosh, I can't talk right now. In the second rational also. Okay, so let's factor. So I'm going to start by factoring this right here. So first thing I'm going to look for, first off, people say not factorable. Did you even bother looking for a GCF? That's always the first thing. There is a GCF. 2 times x minus 3. Denominator. Okay, so denominator is, people will say, is not factorable. I'm okay with you saying it's not factorable. Technically, it factors to 2 times 2 times 2 times x, but no one's going to do that, just like you wouldn't do this, right? Okay, so we're just going to leave it as 8x for now. Times. All right, factor this numerator. Once again, people look at it and they say, not factorable. You have to remember to check for a GCF. They have x in common. All right, the denominator here, you need to factor that. It's going to factor into 2 binomials. So you need 2 numbers that multiply to give you -3, add to give you -2. That's -3 and 1. Divide by your lead coefficient. So you have x minus 3 and x plus 1. Okay, so now what I'm going to do is I'm going to say, okay, I'm multiplying these 2 fractions, so I can just make this all one big fraction where everything's in my numerator up top, everything's in my denominator up bottom, on the bottom. Okay, let's see if anything cancels. We have an x minus 3 and an x minus 3, or we should say anything simplifies. X plus 1 and x plus 1, that simplifies to 1, right? Anything over itself is 1. Okay, anything else? So now you have to ask yourself, can I cancel out this x and this x? Okay, if this was 8 plus x, it'd be bound together and you could not do it. But it's not. It's 8 times x, which means that multiplication implies factoring, right? So this is a factor. So x and x do cancel. Now I'm left with 2 over 8, which is simplifiable. 2 goes into itself once. 2 goes into 8 4 times. So my final answer is 1/4. Okay, they're not always that pretty. Sometimes you're done after, a couple things cancel out. Okay, next one is now division. Okay, so remember when we divide fractions, if I wanted to do 2/3 divided by 1/5, remember to divide fractions, we multiply by this reciprocal. So we keep the first fraction the same way it is, and then you take the reciprocal of the other fraction, so you flip it. And then that would be 10/3, right? So we're going to do the same thing here, okay? All right, so first, just like the last one, I need to factor everything. So that's a difference of squares, x plus 3, x minus 3. All right, this I need to factor. Right here, this I need to factor now. So first, GCF, there is no GCF. So now I'm looking for two numbers that multiply to give me 6 and add to give me 7. That's 6 and 1. Don't forget to divide by your lead coefficient, which is 2. 6 over 2 is simplifiable. It simplifies to 3 over 1. So now that becomes x plus 3. And then this 1 over 2 is not simplifiable, so that's 2x plus 1. Now I need to multiply by the reciprocal here. 4 times x plus 5 is what the denominator factors to. So that's my new numerator. And then my denominator is factorable. Two numbers that multiply to give me negative 15 and add to give me 2, 5, and negative 3. So I have x plus 5 and x minus 3. Okay, now I'm looking to see if anything cancels out. And I do have common factors that are going to cancel. I had to put my mask on because someone's walking into my room. So if I get muffled, I'm sorry. Okay, so let's see what cancels. I have an x plus 5 and an x plus 5. I have an x minus 3 and an x minus 3. I have a x plus 3 and x plus 3. And that's all that I got, all right? So if I look to see what's left over, I have a 4 in my numerator, and I have a 2x plus 1 in my denominator. Okay? All right, so that is simplifying a rational just like when it's by itself. Multiplying two rationals, you simplify, or it's the same, and then you have to simplify it, and then dividing, okay? Last but not least, we have adding and subtracting, okay? So in order to add two fractions, I already erased that original that I had. I think I remember it, though. The 2/3 and the 1/5, I think it was. What if it's 2/3 plus 1/5? In order to add two fractions, what has to be true? You have to have a common denominator, right? So common denominator, the least common denominator for these two fractions is 15. So I would multiply this by 5, and I'd have to multiply the numerator by 5, and then I'd multiply this by 3 and multiply this by 3, and then I get my new fraction, which is 10/15 plus 3/15, which is 13/15, right? Same thing goes for rationals because they're fractions. You need a common denominator, okay? So you look first and say, can I add them right now? No. So what's my least common denominator? So my least common denominator, or your LCD, is this times this, right? X times x minus 2. So I need to get both of my fractions to be that. So I'm going to start off by writing x times x minus 2 plus, and then x times x minus 2. Okay? All right, so I need to multiply this one by x minus 2 over x minus 2. And I need to multiply this one by x over x. So my denominators are done. Now I just have to get my numerators. So 4 times x is 4x. I already put down the plus sign. 2 times x is 2x. 2 times negative 2 is negative 4. All right, now that we have a common denominator, so think about this. If it started off as 1/5 plus 2/5, if you have a common denominator, you keep your denominator, add your numerators. That's what you're going to do here. You're going to keep your denominator, add your numerators, 6x minus 4. All right, now it's back to being just like this problem right here. You have to see if you can simplify it. So, the denominator is already factored. Is the numerator factorable? Yes, there's a GCF of 2. But if I factor out the 2, I'm left with 3x minus 2, and that doesn't cancel with anything in the denominator, so this is done. All right, last one. I need a common denominator. At first glance, I'm like, ooh, what's that? And it's because neither of my denominators are factored. So if your denominators aren't factored, factor them. So this is factorable. Two numbers that multiply to give you 6 and add to give you 5 are 3 and 2. I'm going to cross it off like it never existed. Here, difference of squares, x plus 3, x minus 3. I'm going to cross it off like it never existed. Okay, now I need my LCD, so lowest common denominator. And no, you don't have to do this off to the side. I'm just doing it for thinking purposes. To cover this, I need an x plus 3. And it'll also cover this one right here. Then I need an x plus 2 to cover this. And then I need an x minus 3. So that's my LCD. All right, so what am I missing on this problem here, on this first expression here? I'm missing x minus 3. So I'm going to multiply this by x minus 3. What am I missing on this one? X plus 3, x plus 2 I'm missing. Okay, so I'm going to write what I have left here. So I have my denominators, x minus 3 times x plus 3 times x plus 2. And then I'm just going to write everything in my numerator just because there's so much going on right now. So I'm going to write all of this in my numerator. Well, I shouldn't do that because then I went, here we go, all of this. My pen was too thick there. 3x times x minus 3 minus 2 times x plus 2. All right, now I'm going to clean up the numerator. Okay, so cleaning up the numerator, I'm going to do it right above to save some time here. That's 3x squared minus 9x. All right, distribute there. Now I'm going to distribute this negative 2 minus 2x minus 4. Combine like terms, 3x squared minus 11x minus 4 all over x plus minus 3, x plus 3. It doesn't matter the order that you put these 3 in the bottom, x plus 2. And there is our final answer. All right, you could check to see if it is factorable. It is factorable, the numerator. It factors to 3x plus 1 times x minus 4. But that doesn't cancel out with anything in the denominator. So it doesn't matter if you have this answer that I boxed or this numerator with this denominator. Okay, go ahead and get started on your homework. If you have any questions, please